In this lesson, you will learn how to calculate the volume of pyramids and cones. The general formula for volume of a pyramid is 1/3 times the base area times height. If you will recall, the volume formula for a prism is just base times height, the base area times height. We need 1/3 when it comes to a point for like a cone or pyramid because it is 1/3 the volume of a prism. So let's look at our examples. For our first one, we have a cone. So let's first identify the height of the cone. When you're looking for the height, it will go from the point of the cone down perpendicular to the circular shape. So we want that inside height, not the edge. That's a different value that we will not need. For the actual height, you need the point of the cone down straight perpendicular to the circular shape. For the radius, because we need pi r squared in order to calculate the base figure, we have this value from the center of the circle to the edge of 6 feet. So let's calculate our volume with our volume formula. So 1/3, because it comes to a point, those pyramids and cones will use a volume of 1/3 pi r squared. Because it's circular, pi r squared is the area formula of a circle, and then we have our third dimension times h. So let's plug in all of our numbers. So volume equals 1/3 pi, we will use the pi symbol and not 3.14. Radius was given as 6 squared times our, we don't have a height. So we're going to have to do some work to calculate a height. If you will notice, we are forming a right triangle. Because that height has to come down and meet perpendicular with that circle, it forms a right triangle with that 10. So we'll end up needing to use that to calculate our height, but 10 is not the height of the cone. So let's go down or off to the side and show our Pythagorean theorem work. A squared plus b squared equals c squared, remembering that c has to be your hypotenuse, so that's where the 10 will go. H is what we're trying to solve for. So I'm going to plug in H. You could leave it A or B. It would not matter. But C has to be the 10 because of it being the hypotenuse. So let's calculate that, or let's solve that. I'm going to first subtract the 6 squared. Of course, you could have changed 6 squared to 36 and 10 squared to 100, but since we're going to need to type it in anyways, might as well do it all at one time. So we've got 10 squared minus 6 squared, that is 64. Be careful not to subtract 10 minus 6 and then square that number. That is not the same. Order of operations says we have to square the numbers first and then subtract, following exponents before subtraction. So that's why the calculator is handy, because it will correctly calculate order of operations. So h squared equals 64, but we need to know our height, not just h squared. So we're going to take the square root of both sides. You will only need the positive square root. This is not a case that we need plus and minus square root. Since we're calculating a value that would be a height, it does not make sense to have a negative height. So just the positive square root is enough. The square root of 64 is 8. So we'll go back and use that in our formula for our height. So let's go to our calculator and calculate this volume. So 1/3 times pi, second, and underneath the clear button is where you'll find the pi button. So second pi times 6 squared times 8. We find, rounding to the nearest hundredths, 301.59. We are in feet, so volume is in cubic feet. When you're calculating volume, it's in cubic units. Let's look at our second example. So example number 2. So again, let's start by first finding just the height of the pyramid. So go to the point of the pyramid, and find that perpendicular height that goes straight down to the shape that you have as your base figure. So the height from the point straight down to the triangular shape is this 13. Then when we need to calculate the base area for a triangle, it's 1/2 base times height. So just look at your triangle shape. It might help to cover up the pyramid portion of the shape so that you can just focus on the shape that's the base figure. So base and height have to meet in a 90-degree angle. So find those lines and see if we are given those measurements. So this value here that I would call my height is the 9.22, and then the base that meets perpendicular is 12. They have to meet at that 90-degree angle to be your base and height for that triangle shape. So notice we're not going to need these 11s, it's just extra information. So let's go to our formula. For a triangular pyramid, the volume is 1/3, remembering because it comes to a point, we need that 1/3, times our 1/2 base times height, because that shape on the bottom is triangular, we use 1/2 base times height, and then times our third dimension, the height of the whole pyramid. So let's plug in these numbers. We have 1/3 times 1/2 base times height, so we said 12 and 9.22 times our height of our whole figure, we picked our 13. Once you have all your numbers placed in the correct spots, we can go to our calculator and calculate that volume. So we have 1/3 times 1/2 times 12 times 9.22 times 13. It may be a good idea to double check that you typed everything in correctly since we have so much that we're typing in, but this is the volume of 239.72. We're in yards. Because we calculated volume, it'll be cubic yards. Let's go to our third figure here. It's rectangular on the bottom, so we're going to use rectangular pyramid because it comes up to a point and makes that pyramid shape. So for our height, again, start at the point of the pyramid and find the perpendicular height that goes straight down to that rectangular shape. So 11 centimeters is the height of that whole pyramid. We also need to identify the base figure, the length and width. So length and width, we've got 14 and 8 that we'll use in our formula for the volume. So our formula is 1/3. Again, each of our formulas have that because our volume is 1/3 of a volume of the prism that would be the same shape. Because it comes to a point, because it's a pyramid, it's 1/3 the volume of a prism that would have this same dimensions. So 1/3 length times width times height. Now let's plug in each of those values. We said our length would be 14 times 8 for our width times 11 for the whole height of the figure. So we go calculate that, so 1/3 times 14 times 8 times 11, we get 410.67 because that 6 is greater than 5, so 410.67. Our units are in centimeters, so it's cubic centimeters for our volume. So now let's look at an application type question. Example number 4. We are going to have a cone, so we're talking about a cone, that has a radius that's going to be equal to 5 times the height of the cone. we're going to write a formula that can be used to find height. So write a formula to find height in terms of volume. So I know that seems a little weird, but this is actually very useful with very complicated equations, such as equations that engineers or aviation pilots might use. So this is a useful skill for those very complicated equations, so that we can solve for a variable and be able to just punch in the values that we need. Formula, by the way, ends in an A, not an E, so formula. All right, so here we go. Well, because we know we have a cone, we're going to start with the volume formula of 1/3 pi r squared. The area of a circle is pi r squared times height to get that third dimension. Well, it tells us that our radius is 5 times the height of the cone. So let's talk about what that would look like. The radius is 5 times the height of the cone. So just r equals 5 times h. Because we're writing a formula to find h, so we're just going to solve for h, in terms of volume, we don't want to see any of these r values. So we're just going to replace this in for r. That way all we have left is v and h. And then when it says find h, that means we're just going to solve for h. So we have v equals 1/3 pi, we're going to let our r stand as 5h squared times our height. Using our exponent property, we can square the 5 and we can square the h. Each thing inside of here, because that's multiplication, can be squared. So we've got 1/3 pi, 5 squared is 25, and then h squared, of course, is h squared. And then bring down this last h. So right now we're just kind of simplifying and cleaning things up. Because we are doing that, we can also put these h's together. There's 2 h's there and 1 if you need to write in your exponent. So that means we can add and put those together. So volume equals 1/3 pi times 25, h squared and h cubed. So right now all we've done is plugged in our radius of 5h and just kind of simplified what we had once we plugged that in. So now we're ready to actually start solving for h. Here's the h that we need to get by itself. So there's several things over here that we need to move away from that h in order to get it by itself. Well, already this fraction is bothering me. So let's go ahead and take care of that first thing and get rid of the fraction. So in order to move this fraction to the other side, it is being multiplied, and so you could divide by 1/3. However, the proper way to divide fractions is to multiply by the reciprocal, which means multiply by flipping it over. So we're going to take this and multiply both sides by 3/1, or just 3. So times 3 on both sides. By doing that, it cancels out that entire fraction, and thank goodness we don't have to deal with that anymore. So we have 3v equals pi times 25 times h cubed. Okay, so already that fraction is gone. We needed to move it away from the h. So now we have to look what else is over here with our variable h. We've got this pi symbol and 25, so we can undo those by just dividing. I'm going to go ahead and stick the 25 first. We're typically writing the 25 in front of pi. Although pi is also a number, 3.14, and it keeps on going, we tend to also treat it like a variable. So 25 pi is typically how we would write it. So we can do that on both sides, dividing by 25 pi. So the 25s cancels, the pi's cancels, and we're almost where h is by itself. So actually we have h cubed, let me actually just flip this around, h cubed equals 3v over 25 pi. That's just what it is. So our final thing to get h by itself, because it has an exponent of a cubed power, we can undo that by taking the cube root. You should have undone operations of squares by taking the square root, so it works a lot the same, but we have to think about our index number. In order to cancel that cubed power, we need a cube root. So we will do that on both sides. So this cube root and cubing cancel, leaving our h by itself. So the cube root of 3v over 25 pi. So I know that seems like a very long, complicated process, but now we have this formula for any cone where the radius is 5 times the height that we could calculate the height if we knew the volume. So for example, if we were selling ice cream cones and we knew the volume of the ice cream that we wanted to fill a cone, we knew that value of the volume, we could calculate the height. Of course, it'd also have to meet this requirement of the radius equaling 5 times the height. If you had a different value for the radius, you could still work through this and solve for h.